Alright, welcome back. We are looking at tangents and normals today. This is really looking at applications of differentiation and anti-differentiation. So the whole idea here is if you can calculate the derivative of a function, it's going to help you to work out the gradient of the tangents, and also it's going to help us work out the normals as well. So here's how it operates. If you are given a particular coordinate, so say x1, y1 on a point of a curve, y equals f of x, so you've got an equation. If that is, if you're able to differentiate that at this particular point, x1, then here is how you get the tangent equation. It's going to be given by y take away y1, and that's going to be equal to the derivative at that particular point, so the gradient at that particular point, multiplied by x take away x1. So let's have a look at an example here. Here we've got y equals x to the power of 3 plus a half x squared. And they want us to find out what the tangent is at the point x equals 1. So what you can do is you can find out the x and y coordinates. We know when x equals 1, we can substitute that back into the equation and get its corresponding y value, which in this particular case would be 3 over 2. So the point where we're going to be finding the tangent is going to happen at those coordinates, 1, comma 3 over 2. Next thing we can do is to work out the derivative of this particular function here. So you've got x to the power of 3 plus a half x squared. Differentiating this here, we end up with 3x squared plus x. And we can find out what is happening at this particular point at x equals 1 by substituting that into the derivative. So we substitute in 1 into the derivative, 3 multiplied by 1 squared plus 1, it comes out to being 4. Yep. So at this particular point, x equals 1, the gradient is 4. So now that we know all these pieces of information, we can use this rule up here to work out what the equation is. It's going to be y take away y1, which we said y1 was 3 over 2. So substitute those in there, is equal to the gradient, which we saw was 4, multiplied by, we've got the brackets x, take away the coordinates of the x1 value, which in this particular case was 1. Yep. Now, some people might be tempted to leave it like that. However, it would be nice if we could rearrange things so that we're just left with y equals something. So what you need to do is expand this out. So you're going to end up with 4x on this side, take away 4, and then we're going to have to add 3 over 2 to both sides. Doing that rearranging, you end up with y equals 4x take away 5 over 2. Cool. Now, again, you can do these fairly easily with your Casio calculator. I'll show you 2 different ways in which you can do this. So the first is in the main section. You can go to interactive. You can go to calculation. Obviously, we're dealing with lines here. And for this one, we want the tangent, so use tan line. So we type in the expression. We want to write in x cubed plus a half x squared. So let's do that. X up hat is to the power of 3 plus a half, you can just be written as 1 divided by 2, x to the power of 2, so up hat 2, and it's saying, hey, whereabouts, at which point do you want to find the tangent? We want to find out the tangent at x equals 1. So you put 1 in there, press OK, and happy days, it will spit out the equation. The other way in which you can do it is using the graphics section, or the graphing section. So here you could type in the equation. So it's x to the power of 3 plus a half x to the power of 2. So you could sketch that. So look something like that. Once you have it sketched, you can use the analysis feature to actually get it to sketch the tangent. So you go analysis, you go to sketch. We want the tangent, so you go tangent. It should ask you whereabouts you want, or when it's graphed, you have to say where you want it to sketch. You want it to sketch at 1. So if you type in 1, it'll do the tangent at that particular point. Yep. Now, if you want to know what the equation is of this tangent, you have to press the execute button on your calculator, and it will then tell you the equation, which is 4x minus 2.5. 2.5 is the same as 5 over 2. So that's how you can do it graphically. Alrighty, let's now have a look at the normal. So, let's clear this. So you should be aware of this from previous maths type of learnings. The normal of the curve at a point on the curve is the line which passes through the point and is perpendicular to the tangent at that point. So what you do need to remember is if you've got two lines and they are perpendicular to each other, then when you multiply the gradient from the first line, so m1, and you multiply the gradient from the second line, which we'll call m2, the two lines are said to be perpendicular if, and only if, when you multiply those two gradients together, it comes out to being equal to -1. And from that, if you were to rearrange this here, you could work out that it says if a tangent has a gradient of m, then the normal has the gradient -1 over m, which is just really dividing this by the other gradient, this side by the other gradient. Yep. So it's very useful to know that rule, which will also allow you to remember how to work out the normal. It's got a gradient of -1 over m. So it says here, find the equation of the normal to the curve with the equation listed here, x cubed take away 2x squared at the point 1, -1. Good news is they've already given you the x and y coordinates. You don't need to substitute in to find that. They saved you a bit of work there. First things first, we need to work out what the derivative of this function is. So the derivative of x cubed take away 2x squared is as follows, 3x squared take away 4x. And the gradient of the tangent at x equals 1, what we would do is we just plug x equals 1 into the derivative to find out what the gradient is at that point. If we substitute 1 into the derivative, 3 multiplied by 1 squared, take away 4 times 1, it's -1. Yep. Cool, so we've got the gradient at that particular point at x equals 1. From here, if we've got if we want to find the gradient of the normal at x equals 1, it's going to be -1 over that gradient. So -1 over the gradient which we discovered, which was -1, is going to be -1 divided by -1. -1 divided by -1 is 1. So the gradient of the normal is equal to 1. Using the rule that we saw before, y take away y1 was equal to the gradient at that particular point, so the gradient of the normal multiplied by brackets x take away x1. So we're just substituting all the things that we know into that equation. So y1 was -1, which I put in here. We worked out what the gradient of the normal was. It's going to be listed here as x take away x1, which we saw was 1. From here, it's a matter of simplifying things down. You can expand that out. That's 1 lot of x. 1 take away -1 is just -1. On this side, it's going to be the same as y plus 1. You need to move this +1 over to the other side, so take away 1 from there, take away 1 from there, and you'd get the equation of the normal as being y equal to x take away 2. Happy days. Again, you could use your calculator to work through these. So again, we can go to interactive, go to calculation. Again, we're dealing with lines rather than the tangent. This time we want the normal. So you type in the equation. In this case, it's here, x to the power of 3. So x up hat 3, take away 2, x to the power of 2. And we want to know what's going on at the point 1 again. Here we've got the equation of the normal, x take away 2, or y equals x take away 2. Using the graphing functionality, again, it's a matter of sketching the graph, x to the power of 3, take away 2x squared to the power of 2. We can sketch that. We can go to analysis, we can go to sketch. This time we're not after the tangent, we're after the normal. We type in which section we want it on. We want it at point 1. Click OK. We've got the line for the normal. If you want to know the equation, you press the execute button on your calculator and you get y equals x take away 2, as we discovered. Alrighty, thank you very much for listening. Bye for now.